Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve this problem using logarithm graph. As per the problem, match each equation to its graph. We are given these four logarithm equations and we are given these four graphs. We have to match each of these equations to one of these graphs. The four given equations represent transformed logarithm functions. The first step is to understand the graph of the parent logarithm function. The equation of parent logarithm function is y equals log x. The graph of log x is a curve that has x-intercept at 1. There is a vertical asymptote at x equals 0 or the y-axis. On the left side of the x-intercept, the curve goes in the downward direction along the vertical asymptote. And on the right side of the x-intercept, the curve goes upward in the first quadrant. This is the graph of y equals log x. In order to identify the graph for each of these given equations, we have to know the transformation that's applied to the parent function to get each of the four given equations. For that, we'll have to compare each of the given equations with the general equation of transformed logarithm function. The general equation is different teachers use different letters for A, K, D, and C, but the rules and the transformations are the same. Let's start by analyzing the first equation, y equals log of x minus 3. In this equation, 3 is in the parentheses with x. If we compare this equation with the general equation, we can see that 3 represents the d value. Since the sign is negative in the given equation, the value of d is positive 3 because there is a negative sign in the general equation as well. D results in horizontal translation to the left or right. Since the D value is positive, that means there is horizontal translation to the right side. So the graph for y equals log of x minus 3 is the graph of parent function y equals log x transformed 3 units to the right side. That is the first graph on the right side. Because in this graph, the vertical asymptote is at x equals 3. So compared to the graph of the parent function, the vertical asymptote has been translated 3 units to the right and the x-intercept in the parent function at 1 has been translated 3 units to the right side. So the new x-intercept is at 4. Therefore, this is the graph for the first equation. Now we can analyze the second equation, y equals log x minus 3. In this equation, 3 is not in the parentheses with x. If we compare this equation to the general equation of transformed log function, we can see that c is equal to negative 3. C results in vertical translation up or down. Since the C value is negative, the vertical translation in this case is 3 units down. So the graph for this equation is the graph of parent function transformed 3 units down. It should be this graph here right below the equation because in this graph the x-intercept at 1 has been translated 3 units in the downward direction and the vertical asymptote hasn't moved. It is still at x equals 0 or y-axis. The vertical asymptote does not move if there is no horizontal translation. So the graph for this equation is the second one. Now we can analyze the third equation, y equals log of x plus 3. In this equation, 3 is in the parentheses with x. So this equation has a d value and it is equal to negative 3. Because in the given equation, there is a plus sign between x and 3, and in the general equation, there is a negative sign between x and d. D results in horizontal translation. Since D value is negative, that means there is horizontal translation 3 units to the left. So the graph of this equation would have the x-intercept and the vertical asymptote translated 3 units to the left side compared to the graph of the parent function. And that graph is the first one on the left side, because in this graph the vertical asymptote is at x equals negative 3 and the x-intercept of 1 has moved 3 units to the left. So this is the graph for the third equation. Now we can analyze the last equation, y equals log x plus 3. In this equation, 3 is not in the parentheses with x, so 3 represents the c value. C is equal to 3. C value results in vertical translation, and since C is a positive value, there is a vertical translation 3 units in the upward direction. Therefore, x-intercept of the parent function should move 3 units up, but the vertical asymptote should not move because there is no horizontal translation. And that graph is this third one from the left side. Because in this graph, the x-intercept of the parent function has moved 3 units in the upward direction and the vertical asymptote hasn't moved from x equals 0 or the y-axis. So this should be the graph for the fourth equation. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.